This is his research interest includes materials chemistry, including solar absorber, nanostructure, and porous and non-porous materials. He has also did his work in photocatalysis, functional coating, which is the most interesting, selective absorber, anti-reflective, super hydrophobic, self-cleaning coating for PV and solar thermal applications, and also smart materials, carbon nano, cluster, or flake, or layered materials for thermal and electrical storage. So, Sir CV includes a lot of stuffs that present research I have told you the topic he's working. So he was a DAD research fellow, and most interestingly, 32 patents he is having. So we are extremely fortunate to have such an eminent speaker among us. And major research grants, it is with DST DOE in the US Science and Technology Forum, cost efficient absorber material and selective absorber coatings, development for the design of cost effective parabolic solar collector for OHC system. So it's 2.92 crore, 2.96 crore. So we are very much fortunate, and let's welcome Dr. Shaktivel from the entire Ravindranath Tagore University group. Thank you, sir.
So
Please.
thank you, Dr. Sudhashna. Thank you so much for your nice introduction. So shall we wait for it as a participant? It is a or that's all.
Jyoti madam, did all the participants have joined?
Yes, sir. All are joined, and some people are seeing and listening from the department where single screen. So all are already joined. So we should start, sir.
Only okay. 16 participants.
No, sir. From their department on a projector screen. So by making the social distancing, they are listening from the department, sir. So there are more number of participants. Actually, they are joining via single ID.
No, I think Sangeeta madam is yet to join.
Okay.
So I'll just take 1 minute from you so that I can ask the other people who are supposed to join. Just 1 minute, sir. Jyoti madam, please circulate all other participants who are about to join, but I don't know why, because in last it was like 60. So 16 is a very small number. Okay, let me contact Sangeeta madam by the way.
Okay.
वो मेल आईडी उनका खराब हो गया.
So can you see my presentation slide?
दिख रहा है? देख तो पार्टिसिपेंट कितना हुआ ऑन नहीं करा संगीता मैडम को फोन कर अच्छा बड़ा संगीता मैडम जॉब किया क्या?
No.
उनको भेजा नहीं है क्या?
फोन पे ध्यान दे देना।
हाँ, पर अभी पहले बोलना था तो चल छोड़। फिर मैं ज्वाइन कर लेती हूँ। कहाँ से करें? 30। अच्छा,
Yeah. Shall I go ahead?
yes, sir. It's visible. Yeah.
Yes. Or you can see my presentation now.
Yeah. Yes, sir. We are able to see.
Okay, right. My voice also audible, no?
Yeah, yeah. You are audible, sir.
Yes. Okay. So good afternoon, all of you. And today, I would like to talk about functional coatings. Many of you know that functional material and coating, and that is especially for it is a eco-friendly solar thermal and photovoltaic application. And let me before going to my presentation. So this is you can interact whenever if you have a doubt. The audience can participate in the presentation as well. It's changing my. Now you can see my second slide, no? And before going to my presentation, I would like to briefly introduce my organization. So many of you know that ARCI full form, International Advanced Research Center for Powder Metallurgy and New Materials. So it is an autonomous R&D center working under DST, Government of India. The main objective of this, center is focusing on new material and new technology, development of new materials and new technology development to support our Indian industry. So far, so our center, that organization, it is, we have developed 41 technology, and so we have successfully transferred 41 industries, more than 50 industries, and we have also give solution to various industry, the technological view of problem, and it consists of 11 center of excellence. So among the 11 center, and where the solar one is recently started in a very young, it's not recently started, but it is 2012. It's a very young compared to other center of excellence. Solar energy material is a very new center, and this is our center major thrust area. So we are mainly focusing on, many of you know that photovoltaic. So we mainly focusing on new type of that generation. It is a, photovoltaic cell, especially it's a perovskite solar cell. And then the second major activities is the CAGs, copper, indium, gallium, selenide, thin film solar cell. So apart from these photovoltaic area, so we are mainly working on it is a various functional coatings. But here I mentioned that easy to clean, anti-reflective, anti-fogging coatings for optical and solar and solar thermal application. And apart from that, we recently initiated sensors for it is a various sensing applications. And then apart from these, it is we are also working on it is a reflective mirror and supercapacitor. So this pseudo type supercapacitor also we are working for electric e-mobility application. So these are the center major facility. So this is the first major facility established in our country. It's the first pilot line facility of it is a CHGS solar cell manufacturing facility. And the uniqueness of these facilities, we could make solar cell on 30 into 30 size area. And it is a we have all sort of facility for making cell from lab scale to small. It is a 1 into 1 centimeter cell to 30 into 30 centimeter size large model. So that is our this speciality of our facility. And apart from that, we recently initiated a major facility for making large scale perovskite solar cell. And apart from that, it is any technology. If you want to show that it is a potential and very important for our society. So if you have unless if you have it is a facility for it is a validating the materials or validating the technology. So you could not prove that it is. So otherwise it is a industry won't they won't. It is a preferred to take the technology in order to make more confident to industry side. So we have established a test rig facility for validating different solar thermal component. Especially it is a receiver tube, parabolic mirror, as well as it is a thermic fluid for its a heat transfer application. And this is a key achievement. I'm audible, madam? Can you once again confirm that? It is audible, my voice?
Yeah. That's absolutely
Yes.
audible.
Okay. If it is not audible, you please it is indicate that.
Sure, sir.
So this is a key achievement of our center. And so far it is our ARCA successfully transferred its a 41 technology and more than 50 technology development. And so among the it is 41 hours is 4. So this center it is established 15 technologies and transferred it is a 4 to industry, and few more under progress. And currently it is we are working on 12 project, more than 10 projects. And then now recently we have completed 5 projects. The worth of it is 7.66 crore. Now currently it is we are it is handling it is a 9 more than 10 sponsored project with a worth of it is more than 9 crore. And so far we have filed 19 patents and patent granted 8. And this is the total number of publication from it is a 2012 onwards. We publish 50 and average impact factor is 4.5. So this is what it is our key achievement of our center. And recently we have submitted it is a major project for establishing of it is a technology hub, especially for it is a solar thermal component manufacturing facility at our center with the support of it is a 8 different industries. So this is my first part. So that is what it is my introduction of our center and as well as our institution. And today I would like to it is a concentrate on it is a 2 major areas. So one it is a cost efficient absorber coating for solar thermal application, and so most successful technology. And another one it is a easy to clean coating, that is a super hydrophobic based coating for it is a PV plant, high performance of PV plant uh, PV plant application. Another one it is a anti-reflective coating on it is a PV glass for model manufacturing. So this it is a little bit it is a different from it is a academic presentation. So today I'm going to talk about only how we have developed the technology, and then it is how we are translating the technology to industry, and how we validated and matching with it is in the commercial performance. So that you can show that you can see, and this is what my content of my first part, and I would like to, many of you know that it is a photovoltaic technology. Today I would like to, it is a talk about what is the status of it is a different energy conversion technology. And apart from it is a photovoltaic, it is solar thermal, we are mainly, it is a concentrating right now. And what is a key importance of solar power generation in India? And then what are the components mainly? It is working or play an important role in this technology. And then current status of this receiver technology, and how we developed receiver tip technology by using it as a cost-effective process. And then how we validate this technology. So, and history of development of it is the technology when we developed, and it is a how where we are right now. So all those things it is I would like to discuss in this first part. So here you can see that it is a, before going to it is a generation part, generation of it is a power. One should know that it is a, what is our consumption, what is our production capacity. So here you can see that. So our capacity of it is a power generation. It's a more than 300 gigawatt power we are generating from different sources. How we are generating here, you can see that. So among the, it is a different source. The conventional thermal power generation is a major part. How we are generating it is a, we use it is all three major, it is a puzzle fuel, it is especially it's a coal, gas and oil. These are the main three resources we use to develop it as a power by using it's a conventional thermal power plant. And these are the major, this is the major, it is a power generation source in India. So mainly it is a coal, it's coal based thermal power plant. It is a play an important role in our country for production of it is in our power. And the rest it is a 3.3, and it is from nuclear, and then hydropower it is 11 percentage, and wind. And you see that it is a where we are utilizing it is a this power. Mainly it is a, we utilize its a power in the industrial sector. So more than 40 percentage it is a, we are utilizing whatever power we are generating by all these sources. And then it is in the second major one, it is a domestic, it's a 24 percentage, and agriculture it is 18 percentage, and commercial and 9 percentage, and other miscellaneous it's a 7 percentage. So these are the, it is a where we are, how we are it is generating our power, and where we utilize in this. So, and as per it is a that energy association, it is a report, world energy association report, due to our fast globalization, as well as it is industrialization. So our consumption rate is increasing day by day. And in 2050 we are end up, it is our requirement, it is a power requirement is around, it is a 13 it's a 30 terawatt. So currently in the global. And then you just imagine it is a if we go such a fast consumption of it is a fossil fuel, and how long we can utilize all these three fuel. Mainly it is a coal we can utilize 200 years. This is as per it is a association energy, world is energy association statement. And the natural gas it is a 60 years. And this statement it is based on the current available resources in the earth. Not it is based on there is any new findings. And the oil we can utilize it as a 30 years. So, and in the 2050, our consumption rate will be double what we consume right now, and currently it is consuming 50 terawatt in globally, and then it is in 2050 we need it's a 30 terawatt. It is uh, power for, and just imagine it is apart from this energy
Sir,
crisis
sorry to interrupt, but your voice is
because of
little
its emission of
breaking.
gases of fuel, and another major issue is so we largest producer of CO2 gas.
Sir,
So
your
the major
voice is little bit of
contributor.
breaking. Sir, sorry to interrupt, but your voice is breaking from just now. So if you kindly check the net connection over there, because till now it was fantastic, but just now it has started a little bit of breaking your voice, sir. No, sir. You are not audible, sir. I think she'll join. Sorry for the interruption. I think sir is going to rejoin because of some network issue from his side. So I'd like to request all the attendees and the participants and the panelists to have patience. I think very soon she will be joining. Sir has joined. Oh. Okay. I'm extremely sorry for the interruption. I have just talked to Dr. Shakti Khel. He told that there is some problem from his side in the internet. Within just 5 minutes, sir is going to join. So I'd like to request all of you to have 5 minutes patience. Thank you. I have again called up Dr. Shakti Vel, and he told that his technician is now reconstructing the link. So I'm extremely sorry for this technical issues. And I'd like to request all of you to have 5 minutes more patience. And Jyoti ma'am, if you circulate this through the chat window, then I think it will be good.
Your computer. Now it's coming, sir. Everything coming. Fine. Yes, listen.
Right.
Okay, sir.
Yeah, thank you, thank you.
Yes.
Hmm. So can you hear my article?
Yes, sir. This time you are audible.
Okay, right. So now I share my screen once again. Okay. Can you see
Yes,
my
sir.
presentation? Yes?
Yes, sir. It's visible.
Yes, okay. So coming to that, it is a energy crisis, and the other major issue on global warming, because we are the fourth largest CO2 producer, and here these are the it is a natural disaster causing by that global warming. And recently, you can observe that it is in California, nearly it is a 1 lakh acre, more than it is a 10 lakhs, sorry. So 10 lakhs, it is a land, it is in the forest land, it is a completely, it is a burnout. Because of that, it's a natural issue. So earlier, it is a, the US people, it's not bothering about this global warming, but now the new administration, it is, again, it is ready to join that it is a global warming issue and to resolve this problem. And this is a one, it is I would like to highlight. This is a person, maybe, um, I think it is some of you, it is uh, you can guess who is that person. And why this is very important, it is he realized that it is the importance of solar energy some 100 years before. So he made the very highlight of this solar, the importance of solar energy, and he made us highlight. I would put my money on the sun and solar energy, what a source of power. So that's what it is. He realized 100 years before. He is none other than it is a Thomas Alva Edison. I'm audible, madam?
Yes, sir. You are audible.
Yes, yes. So it's 100. Just imagine it is a 1931. It is he died, and before, and he made this the world important. It is importance of it is a solar energy. Now the whole world realized that importance of solar energy, and recently our our former prime minister, it is Manmohan Singh, who in 2010 he announced it is a solar mission, and there it is a and he initiated it is a solar mission program, and initiated it's a various, it is a joint technology program. This is one of the major, it is a joint consortium, Indo-US consortium, and we were one of the member in the consortium and received it is a more than it is 3 crores, and for establishing new technology for both solar photovoltaic as well as it is a solar thermal. And why? Because it is so our country is a gifted country. It is a blessed by it is a God in such a way that it is we are getting it is a very clear weather, sunny weather around 250 to 300 days, and more than 500 trillion kilowatt hour radiation hitting on our land. If we can manage to take tap at least it is a 5%, we could resolve the energy issue for the whole world. So that is what it is a main the key importance of this technology. And coming to that conversion technology, many of you know that it is these are the two major technology. So one, it is a photovoltaic. Many of you know that in principle photon, it is a convert to it is a electrical energy by using it as semiconducting material. Whereas in the case of it is a solar thermal, it is a multi-step process. Photon energy converted into heat energy, and next to mechanical energy, and finally it is a electrical energy by using of it as a collector. So we use it as a here that receiver tube, that is a block absorber coating which absorb light and which convert it as a photon energy to phonon energy. It's just for it is a vibration energy which causing its heat. And the potential advantage of this technology is it's a high performance compared to it's a photovoltaic, and we could it is a store energy, and as much as thermal energy in the form of heat by using of it is a very cost effective storing material. That is a key advantage of this technology when compared to it is a photovoltaic. We could also it is a store, it is a electrical energy generated by it is a photovoltaic process, but it is a by using it is a battery for storing the energy, it is a bit costly because the life period of it is in a battery it's around three years, and it's a quite expensive. And compared it is in a photovoltaic, the solar thermal, it is a very easy way to store the energy. And we could run the plant, it is right off the sun down. And this is what it is that the technology importance. And here you can see that in principle, solar thermal plant, it is a functioning as similar as our conventional, it is a thermal power plant. But there is only one difference. Here you can see that the solar collector which comprise of it is a parabolic mirror, and then it is a the receiver tube, which having it is a high selective absorber coating, which absorb its radiation from it is a 300 to 2500 nanometer, the whole sunlight radiation absorb, and which that is a only one difference to make steam, to generate steam by using the solar collector. Otherwise, it is a this technology is entirely it is a similar, in the as similar as it is our conventional thermal power plant. So the potential importance of this technology, there is a European Solar Thermal Electricity Association. They nicely highlighted that, and this is a word it is they used. This technology would be, the CSP technology would be enough to cover the full electricity, because if we can use 4% of it is a Sahara Desert, with this technology, we could it is a produce it is a energy requirement for whole human race. That means it is a whole global. So here you can see that it is a Sahara Desert. The total area of Sahara Desert is located in North Africa. So it is around, it is a 96 square kilometer, 96 lakh square kilometer length area. And you just imagine it is a 4%. It is a 2 times of our Thar Desert area. And so if you can use 2 times of Thar Desert area with having this technology, we could run, we could it is a generate it is a power for our whole world. So just imagine it is a how much area it is required for our India. So roughly it is around 30 to 40% Sahara Desert area is required for our purpose, and you can understand that it is the importance of this technology. And whether it is a very successful technology or not, this is a well proven and successful technology in well reported in it is a 1987 onwards. So this is the first plant. It is established in the California Mojave Desert area. So where we can it is a put this plant, it is a whereas where we have it is a the desert land, it is a well suitable where we can get more DNA. So that's what it is, this technology. And when Prime Minister, it is a former Prime Minister Manmohan Singh was announced solar mission, that time it is we didn't have any single technology, it is a single plant in India. So after that we have successfully established more than it is a 10 plant, and you can see that it is some of the plant it is running in a very nice manner with high output. And these are the it is a coming to that is a different component. This is a very key component. This is a receiver tube, which comprise of it is a 3 important coating. One, it is a high selective absorber coating. Another one, it is an anti-reflective coating. In order to avoid the dust deposition on the mirror, and as well as it is a PV panel. So there is another important coating. It is a dust repellent coating. It's also very important for this photovoltaic as well as solar thermal field. And the key requirement for this coating, so the coating should absorb it is a radiation from 300 to 2500 nanometer, as I mentioned. So the whole solar spectrum can utilize, the whole sunlight can be utilized for generation of it as a heat energy, for production of it as a power from solar thermal route. Whereas in the case of it is a photovoltaic, we could utilize 50% of light from solar spectrum. So the remaining 50% it is not useful for it is a semiconductor photovoltaic application. So another important coating it is a this anti-reflective coating. So generally it is a glass. It is a reflect. It is a 6 to 8% of light, and so which absorb it is which transmit it's around 90% of it is a light. So in order to enhance the performance of the receiver tube, the people used to it is a put it is a anti-reflective coating over on the glass surface which cover over on the receiver tube. So that's a AR coating. It is a huge requirement for such application, and so this is it is a basic fundamental. Many of you know that it is a solar spectrum. It is a starting radiation from 250 to 2500 nanometer. And what I already mentioned that solar thermal application, we could utilize the entire radiation for solar power generation, solar thermal power generation. Whereas in the case of it is a UV, we could use only 50%. The radiation starts from 250 to 1100. That is a half portion. Only 50% light can be utilized for photovoltaic application. And so very important functionality for this receiver tube, the coating should absorb radiation. At the same time, it should not allow the heat radiation from the system. So why? Because so once this black coating absorb radiation from sunlight, it is around 95%. So what will happen? This is a plant. It is a solar thermal power plant. So the morning, if you run the plant, so the thermic fluid start from here. So in the one end it start and it moves one after another. It is in the receiver tube. So each receiver tube length around 4 meters. So what will happen? It is if the thermic fluid moves from one end to other end, it tracks it as a heat from the sunlight. So the absorber coating will absorb the light and convert it as a photon radiation to phonon radiation. Then it converts into it as a heat radiation. After that, it transfers the heat to the thermic fluid. So once if the thermic fluid it is heated up to 100 degrees centigrade, it starts to emit more radiation. So if in order to reduce the emission, the heat radiation, so the coating should not, it is allow any thermal radiation should escape from the system. So otherwise it is we cannot utilize the radiation. It is a power generation. So for that reason, it is this coating. It is it should have both functionality. One, it is absorbing capacity, absorption of radiation from sunlight, and other characteristic, it is a protection characteristic. Once if the heat radiation forms, the coating should repel the radiation inside the thermic fluid. So for that reason, it is a coating should have a high configuration, which has it is a metal and metal ceramic type. These are the basic characterization. This is one of this is a special characterization technique for measuring the heat loss property of the coating, as well as we could measure the exact heat loss at various process temperature. This is only one unique equipment. It is a measurement unit. It's available in the country. So we purchased this the unique measurement. It is in 2010, and this is we can exactly calculate that it is a thermal heat loss, as well as it is how much radiation it's absorbing by the coating. So that is it's a key requirement for this analyze the property of the coating. And this is apart from that power generation. So most of our power, so what I already mentioned that it is we are generating it around it is more than 300 gigawatt electricity, and among that it is 100%, it is we are more than it is a 32% of energy. So we are it is again utilizing the electric power to convert it is electric power to the thermal power. So for that reason, it is this plant it is well suitable for it is a very industrial process heat application, and this is another very large potential application for that. To be frank, it is in 2009. There is only one technology available in the country, so that is NEL technology. So that coating it is developing by it is an electrochemical process, and there is most of the plant running by using of it is a commercial the tube are being developed by sputtering process, and these are the key technology is available from different, it is a country, and this is a, receiver tube is a very expensive. So for this requirement, it is we required coating on 4 meter, and the cost of the coating is around, it is 1 lakh. This receiver tube cost around 1 lakh, and no Indian industry interested to take such kind of, it is a technology for manufacturing in India itself. So there is a no indigenous component development facility available in India. To avoid that, ARC has, it is a participated to develop in the coating development on, it is a, for receiver tube development application, and we have recently, it is a successfully developed, it's a 2 meter, it is absorber coating, and this is a key importance of our coating. It is very easy to scalable, and it is a very cost effective process, well suitable for our Indian industries. And this coating is comprised of 3 important layers. So the first layer, it is a composite oxide layer. The second one, it is a sol-gel based layer, and the third one, it is a nanoparticle layer. Will all 3 layer, it is which gives it is a more than 95% it is absorption. That is a key requirement for this technology. So here you can see that it's a very easy, it is a process we could make. It is a so stainless steel tube, polished stainless steel tube 304 and 202 tube we are using. So generally it is a stainless steel tube. It is comprised of multi metal component, so which mainly comprise of iron, chromium, nickel, and manganese. So what we are doing is we are using it as a special composite acid chemical bath, and to oxidize the metal into metal oxide. So we are making it is a very fine layer. The thickness around it is a 200 to 300 nanometer. So here you can see that it is a the best layer. What we observed, it is 160 nanometer layer, which gives it is a very good optical absorption, as well as it is a good stability. So which after that, it is after developing this layer, we have studied this layer by XPS analysis, and we have observed that it is all the metal component is converted to metal oxide. So that we can see that it is oxygen peak corresponding for all the metal. We can easily identify by XPS measurement, and the maximum property we observed is 91.5, but which shows it is a very less, it is a mechanical stability as well as it is a thermal stability. In this case, it is we used that 80% optical absorption layer, which shows very good thermal stability as well as a mechanical and corrosion stability. So after that, in order to, for this application, the coating should must have it is a more than 90%, and for that reason we have applied another nano-composite layer by using it as a dip coating process, and this is a very so the only thing is it is if you can say potential technology. So that technology should have it as a high scalability. So until unless if we are not able to make in a large scale suitable for industrial application, so this technology you could not say that it is a very successful technology. So in this case, it is all this technology, it is very easily scalable and cost effective. That is a very key requirement for this technology. After applying this layer, we obtained it is a 92% optical absorptance. And this is a third layer we applied by using of nanoparticles synthesized by hydrothermal process. So this is a very unique way we developed nanoparticles. Most of you know that it is how nanoparticles are developing by various process. There are two main route. It is a step down, it is a step up process. So this is a process we used very cost effective commercial micron size particle. So that is a magnesium fluoride. It is available in the market, and we use the magnesium micron size particle to convert into it is a very fine uniform. It is a hollow porous nanoparticle. So that is a key advantage of it is a particle. For any optical coating, by using of it is a nanoparticle, the particle should be more uniform and well dispersible any sort of it is a solvent. Otherwise, it is we could not make it. It is a any uniform coating for such commercial application, and we have very well successfully. It is a, we developed very uniform. It is a porous and hollow particle, and we have filed it as a 3 patents from this. And then we have successfully developed this material in a large scale, and we well dispersed in a polar solvent, and it is we make it is a very uniform coating. And here you can see that it is I already highlighted that until unless if you are not able to validate your technology by using it as a kind of in a real field condition. So the technology it is we cannot make it is a more attractive to the industry. So for that reason, it is we have upscaled that it is a coating on it is a 1 meter, and after that it is we have joined it is a 2 meter, and this is a commercial receiver tip 2 meter size, and then so we have successfully it is a validated. This is a coating process. It is I just wanted to show this a coat how we are making. You just have a look. You see the video. This is a 1 meter. It is a receiver tube. Just 10 to 12 minutes, you could get it is a very uniform coating. After that, it is this coating. It is a validated. This is a validation facility. I already mentioned that we received a major project for validating of it is a this such type of it is absorber tube, and recently we have established this facility now at our center and inaugurated by our director. It is Dr. G. Padmanabhan, and then and this is a this is a very the nation this is a first. It is a unique first in kind of it is a district facility available in the country. It is a very unique application, and we could validate all the 3 components. What I suggest it is a receiver tube as well as it's a parabolic mirror and thermic fluid. And then with having it is a measurement of it is a direct normal direct irradiation, normal irradiation, as well as the global normal irradiation. So for measuring for calculating the efficiency of the receiver tube, as well as it is calculating the efficiency of the photovoltaic cell as well. And this is a the testing facility. I just wanted to show that it is how it is operating. So there is a small video. This is a automated. It is a auto sun tracking mode system. The uniqueness of this testing facility, we could it is a compare the performance of the receiver tube with commercial receiver tube. And this is a focal point to concentrate the solar light towards it is absorber tube. And this is a expansion tank for it is a thermic fluids circulation, and this is a thermic pump to circulate it is a thermic fluid to harvest it is a heat energy from the receiver tube. And this is a pyranometer for measuring the GNI, and the pyroheliometer for measuring it is a DNI or direct normal irradiance. And this is the first initially it is we compare the performance of it is a commercial receiver tube with keeping it as a receiver tube in both side, and we observed it is a very identical performance of it is a power thermal power generation, and then after that, and we replace. So one end it is we fixed it is a commercial one, another end it is a our receiver tip, and we compare that it is a performance with a commercial one. So ours is a little lower when compared to it is because our coating it is although it is a very cost effective, and it is a very less, it is a 93% absorptance, little bit it is a lower than commercial one. Commercial one it is a 95, the optical absorptance. But the advantage of this technology, it shows very less heat loss property compared to it is a commercial one. That is a key advantage of this technology. And with that success, we have successfully transferred this technology to one industry, and now we are it is a trying to it is a transfer to three more industries who is interested for it is a solar water heater, as well as it is industrial process heat application. And this is a it is a the level we in 2015 we started like it is a 20 centimeter length, and then we step by step we have developed our coating on larger size, and recently we established on it is a 1 meter, and that it is we have successfully it is a made prototype receiver tip. And this is a success story of our technology, development of our technology. We initiated in 2012 as a MSc master project, and then it is we received pre-course project in 2016, and then we successfully it is a developed prototype receiver tip in 2018, and then 2020 we have successfully established test rig plant, and also it is validated, and then we successfully transfer the technology. And later it is this is a major plant we are going to install this receiver tip for it is a field validation. So this is a large scale validation at plant level, and this is a one it is a we are going to do next. And apart from that, the earlier technology is well suitable for it is only industrial process heat application, which is suitable for it is a maximum operating temperature around it is a 250 degrees centigrade. For power plant application, the coating should have it is a high stability, more than it is a 500 degrees centigrade. It should withstand, and for that reason, we have it is chosen it is a spinel material. The spinel material it is a one of the it is a stable material, which and stable up to it is a 700 degrees centigrade, and also it is a it has it is a potential advantage as it is a high optical properties. So with that, it is we successfully developed a 1 meter tube for it is a coating for it is a power application. So this is what it is another this is a major project we received from industry, and DST project, and it is a more than 2.5 crores project it is we received, and then now we successfully it is a established 2 meter coating, and then next we are going to it is validate this coating. And this is a key feature of this technology. You can see that it is this coating we have in order to prove that this is industrially it is a suitable or not, and we have heated it is a 500 degrees centigrade till 250 hours, and we check the stability of the optical absorptance of that coating, and till 250 there is no loss in the optical properties. Here you can see that it is a optical properties not changing, it is increasing, it is a with increasing how it is curing curing process, and it is a very one of the so this is a first a technology available in the world which is suitable for it is a running the plant it is at open atmospheric condition. That is a key advantage of this technology, and which has it is a high optical absorption in all the angle. So as you many of you know that it is a sun angle is vary with from morning to till evening. So the coating it is if you have it is a kind of smooth coating which is developed by its sputtering process. So it doesn't have any kind of it is angular selectivity. But when we go with it is a nanoporous, and then kind of it is a spinel coating which has a fine pores and nano white which reduce the scattering process. So light comes in any angle, it is a which absorbs it is a more. You can see it is a 10 to 50 angle. There is a no big loss in the optical absorbance. That is a key advantage of this technology. And this also we are it is planning to validate in the plant level as well as it is technology transfer. So let me know it is how long I should go. It is another 10 minutes. Can I take?
Yes, sir. Yes, sir. Please, please.
Okay. So this
15
is
minutes also you can. Yeah.
okay. 10 to 15 minutes I will complete my presentation. So this is a second important technology. It was a it's a key requirement for our country. So you just see that it is a in 2010 when solar mission announced at the time our capacity was for power generation by using a photovoltaic only 50 megawatt capacity what we heard it is earlier. I was it is a I have presented my presentation in Jodhpur IIT, and that time it is a in 2016 onwards. I used to say that it is a the solar mission objective. Here you can see that in 2010 when solar mission announced, our objective was to reach 20,000 megawatt solar power capacity by 2022. So, but at the time in 2010, we had a capacity, it is only 2000, 50 megawatt. So in nearly it is a, you see this 2050, how much it is a big difference. It's like it is a mountain-like objective, and at the time we were in the bottom of the hill. So I was very surprised it is how we can reach the objective by 2022. But very surprisingly, so we noticed that it is a, in 2020 itself, we reached 35 gigawatt. That means 35,000 megawatt of solar power capacity by 2020 itself. Now itself we reached it 35 gigawatt. So what our government it is, now they realized and now they scale up the objective. It is now the objective is to 100 gigawatt. That means it's a 1 lakh megawatt power capacity by 2012. I hope it is it's a we could reach, and this is what it is a PV capacity. PV it is a very photovoltaic power generation is well suitable for India, and now with a great support of it is the government as well as it is industrial participation, and it is a very key success of this technology. And now I already mentioned that it is in 2012 it is we need to reach it is 1,000, but surely it is we could we have a chance to reach it is this 1,000 100 gigawatt, or at least it is a 50 gigawatt. And this is a complete renewable power generation in India. So here you can see that it is a now. This is solar. It is a total power generation. It's a current status 362.7 gigawatt. It's a power generation from our total power generation capacity. So among the it is a, this total power capacity, our renewable capacity is around 82.6 gigawatt, which comprise of it is a both solar PV as well as it is a wind, as well as and also it is solar thermal. So now you see that it is a solar power capacity. It is our contribution is 9%. It started in 2010. It is a less than 1. The fraction of it is a percentage of it is a contribution. Now we reached 9%. If we compare in the in the global status, so our contribution is around it is 3 to 5% in the global. That is very amazing for such technology. The major issue is, although it is a potential issue, and why this technology it is now it is handling some issue. You see that it is, although it is a potential technology, there are 4 major reasons to hurdling this, or reducing the performance of the power generation from this such plant. And one, it is a reflection losses. Another one, it is a glass corrosion. Another third major one, it is soiling loss. You know that it is within 1 month. So actually, it is a solar panel or an solar collector. So both are, it is traditionally mounted in outside. So because it is in order to harvest, it is a more energy. It is a focus on sunlight. So for that reason, it is a this device, it is mainly exposed into all, it is a environmental condition. Mainly, it is a dust is a major issue, and within a month, it is a our the panel gets, it is a 4 gram per meter square, which decreases it is a power generation by 40%. And that is what is a major issue. If anyone it is a make it a suitable technology to avoid a dust repellent, and it is managing, it is apart from these three losses, there is another losses. It's a temperature effect. So in the summer, it is a, that panel, it is a heated up, it is a maximum, it is 70 degrees centigrade. And the the best efficiency panel you could get, it is a, around 25 degrees centigrade. The best efficiency of it is a 15 to 20% efficiency you can get, you can observe per panel at optimum operational condition. So 25 degrees centigrade. And beyond it is every degree centigrade, the efficiency will going down. So if we can make it is a good oil, anti-soiling, as well as it is a thermal protection type of coating, that is a key advantage for this such PV application. So here, this is one of the largest PV power plant established in our country. And now recently it is a, in the Karnataka state, it started, it is another 1000 megawatt power plant in one area. And this is the first one, it is a, the largest one established in Kamudi in Tamil Nadu. And another major issue, in order to remove the dust from the panel, so they use it as a lot of water, it is a, from the ground, so this plant, it is they are using 2 lakhs liter of it is a, water per day. So that is another major issue, is a lot of consumption of water. It is for cleaning the panel. To make it, it is a, more, make it as the panel, it is a, performance, it is a more. So this traditionally it is people use it is a 2 cleaning process. One, it is a traditional, it is a manual cleaning by using of it is a the mechanical scrubbing. So here you can see that it is the man is cleaning mechanical, so with using of it is a scrubber. And if you use continuously for cleaning by such process, so you know that it is a, the panel, it is a top cover, it's a comprise of it is a glass. So if you use continuously for cleaning by using it as a hard mechanical process, you may scratch the it is a surface within a day. So in a year, it is a 1%. It is a the people calculate normally if you go with the gentle cleaning, so 1% loss in transmission they noticed. And by if you go with unskilled, it is a cleaning, manual cleaning. So you just imagine it is. So how fast it is that the people will clean, scratch it is the glass. So once if the transmission goes down, ultimately the performance of the coating, performance of the panel also decrease very drastically. So in order to avoid that, people use it as a robotic cleaning. So in order to fix robot in the plant, it is a every rail. So we used to say that it is a one rail for one robot. So if you want to, it is a use it as a robot for it is a 1 megawatt power plant. You need to, it is so around it is a 3000 panel you need to clean. For each row you have to fix it as a each one robot for cleaning. So it is a very expensive process to maintain the it is a plant. So in order to avoid that, any technology suitable for it is easy to clean. So these are the coating technology. It is people attempted. So one There is a two different types of it is a dust repellent coating. That means anti-soiling coating. People tried so far. One it is a super hydrophobic, another one it is a super hydrophilic. So here you can see it is a super hydrophilic. It's a kind of lotus effect. Okay. So the lotus, it is a tree. It is a gifted by it is a it's a, God already created. Is such a nice technology. You see, this a lotus leaf comprise of it is a a kind of it is a protuberance, which covering it is a paraphilic kind of it is a low surface energy fill over on the it is a protuberance, which that is a main reason for getting the hydrophobic property. When the water it is a fall on the leaf, it will roll. Whatever it is a dust deposited on the leaf, it will take away it is very easily by pouring of water. When the water is a rain comes, it is very within a minute it is the dust will remove by using of this water. So that is a principle. We the hydrophobic principle. Another one it is a hydrophilic coating. People are using it as a titanium nanoparticle as a coating material, and which gives it is a kind of it is a hydrophilic property, which gives it is oxygen vacancy. When you pour water on the surface, water move like it is a very tiny film. So with a tiny film, it is very difficult to push the dust. So that is what it is. The problem with it is hydrophilic type of coating. In this case, it is a hydrophobic is well suitable for it is a easy to cleaning of it is a PV panel. And this is a principle. It is a we also adapted for our technology, and we have successfully developed a technology which has this is a joint development. This project it is we received from NTPC, and NTPC wanted to develop a coating with high transmission and without it is a, reducing the transmission of the panel. So although it is a this coating will provide it is a dust repellent property, but it should not reduce the transmission, actual transmission of the the panel. That is a key advantage, key requirement for such type of it is a coating. So apart from that, it is in a transmission without the reducing of transmission. So this coating should withstand it is in IEC standard 61646. So this is a standard, a type of accelerated test which comprise of it is a high humidity freeze test, thermal cycling test, and damp heat test. So these three tests, it is a total duration hours 1500 degree, 1500 hours test. And why this test it is a people it is a demanding, because that PV manufacturer, PV model manufacturer, they are giving warranty 20 years life warranty of this panel, because after validating this panel by using of this IEC standard test. So as per it is a NTPC requirement, they demanded that it is our coating should withstand this test. So we have successfully developed this 11 composition. Out of 11, it is a 3 were success, very passed this validation test, and all the 5 so among the it is 11. We also it is a compared with the 5 commercial one. So all the 5 commercial one it is not withstand this test, and with that positive result, we have successfully validated for various. This is a very simple process technique. You can see that it is a the panel size around 1 meter into 2 meter, 2 meter length and 1 meter. So if you want to coat this coating in the field, the coating should be curable at ambient condition. That is that is also it is another important requirement for this coating. So we have successfully developed a coating formulation suitable for it is a curing at ambient condition with a high transmission, high hydrophobic property, as well as it is a high weather stability withstanding it is IEC standard. So how this coating process also very simple. You can see that this very simple. It is a spray coating process. And this is for very easy spread coating. And this is one, it is a, an action of it is a dust repellent, how this coating, it is a pulling the dust very easily. You can see that in this video. And this is be accelerated. So you can see that it is in a
पता नहीं मैंने
coating
किया था
panel.
ये देखो वाह मतलब मैम स्पीकर ऑफ है
This is a coated panel. It is a, when water, it is a, flow, very easy to remove the dust without any brushing.
वाटर तो लगेगा
So whereas in the uncoated panel, you can see that it is when you pour water, so it's very difficult to remove dust from the panel. So with the success, with the positivity of it is a, in the laboratory, valid test, and we have, applied this coating, on the panel, it is in the field level, and we have tested this panel, for 2 months, and we have observed its high performance. With that positive result, and we have validated this coating also in the plant level, and the plant, it is a, belongs to, it is NTPC Limited, Noida, and we have, after it is a 2-month validation, and the coated panel shows it is a 7.5% enhancement compared to uncoated panel. And this coating also, it is validated by standard test by CPRA, Central Power Research Institute. They have validated right after coating. As per it is NTPC, this coating should not reduce any transmission as well as power output. You can see that it's right after coating. So this is a before coating, it is after coating. So there is a no power out, power diminish, there is a power enhancement we observe. And with that success, this technology has been transferred to NTPC in 2019 April. And then now this coating demonstrated to various, it is a PV manufacturer as well as it is a plant developer. And this is a major, it is a demonstration in the rooftop power plant. So this is a power plant, it is a 0.5 megawatt power plant. The one industry, it is a fourth energy partner, Hyderabad, they established plant on the, it is a big commercial complex. This is a Spark commercial complex, and this is a very top side. It is 100 meter away from the ground. So where it is a how that there also it is a very fine dust only it is a play on that. So in that we have applied 72 panels and we have validated the coating for it is a 4 months totally, and we observed 1.7% enhancement. So what is the advantage of it is by using this coating? So this coating won't give it is a high performance when compared to it is it. But the advantage of it is a coating is it gives it is a very easy to maintain the panel without it is a frequent cleaning. You can it is a, every week it is a people use cleaning the panel in the plant. So instead of it is a cleaning periodically every week, so you can postpone it as a the cleaning. So you can instead of it is a 1 week, you can go it is a 1 month. So in this way, it is a you can reduce it as a power consumption as well as it is a uh, labor consumption and water consumption. And that is a key advantage of this coating. And apart from that, there is it is an enhancement. It's a very little. It's not. It's a very big. It is a 2%, 2.5% in the plant level. It is not very high power enhancement, but it's quite good. So if we the coating cost, what we estimated is around 200 rupees per panel. And if the panel the coating we give it is a warranty for it is a 3 to 4 years. So if the coating it is a stable up to it is a 3 years, 3 to 4 years, you could save it is a 430 per panel. And because of this economic cost, calculation, it is a calculation, and this technology has successfully transferred into to industry. And apart from that, this is what it is, AR coating or it is a PV application. So what I already mentioned that we have successfully developed a nanoparticle by hydrothermal process, very easy approach. So from micron size to it is a nano size. So the advantage of it is a coating is it is very uniform and high performance. It is a more than it is a 3% enhancement in one single side. And so here you can see that it is in two side you can get it more than 5% in some cases. And apart from that, this coating it is due to because of nanoporous and nano void. This coating it is showing it is a very omnidirectional property because the panel it is running from 10 o'clock to it is 3 o'clock. It is active a time. So during this time only it is a maximum power we can generate by using of it is a photovoltaic panel. And then in that it is a duration, it is an angle will change every hour, every 15 degree angle it is changing, it is every 1 hour. So if the coating it is angular, it is a omnidirectional property, it won't reduce any. So without coating you can see that it is a bad glass showing it is a very drastic, it is a decrement. This right after it is a 30 degree. So whereas in the case of it is coating, it is showing it is a better rate of transmission throughout the angle. And with that, we have it is a measured that it is a model performance. You can see that it is the overall power enhancement and the 11% enhancement we observed by using of it is a air coated panel. So that is a key advantage. And recently we have also established a test rig facility for validation of it is in a PV model as well. So this is a key, the very important. It is equipment you could measure that it is a field factor, power, it's a current measurement, voltage measurement in the throughout. It is in a day, and you can see that it is a power. The advantage of it is a coated panel, how it is performing well compared to uncoated one. So that is it's another technology with that success. And Borosil, the company who is making it is a PV glass in our country. That is the only one country it is making PV cover glass. So for it is for supplying up it is a entire it is that PV industry, PV model manufacturing industry in our country. And so they are more interested to take our this technology, and they requested to demonstrate this technology at their scale. It is industrial scale, and we have signed it is a NDA and option agreement with them, and to demonstrate this technology to Borosil, and also it is after that it is we transfer the technology to Borosil. So these are the three major technology developed in our center, and we successfully it is validated in at laboratory scale and standard test condition as well as field condition. That is a very essential to show this technology. It is a more potential and suitable for industry. So this with that positive things that as I conclude my talk, and with convey my gratitude to I thank all my team member. This is a technology development team, and this is a team. It is a whole overall solar thermal group, and also I thank it is our director and our former director who supported and trusted us to I have joined it is in 2010. Immediately it is our former director it is supported with it is 2 crores of money to purchase of all the necessary equipment and facility in our center. And once again I thank you all, and so for your patient hearing. Thank you. Thanks so much. If you have any question, it is you can ask.
Yes, sir. Thanks a lot for this wonderful talk as well as very much vibrant slides. PPT, we can say. And okay, sir, we have some couple of questions, just like for this anti-dust self-cleaning coating. What is the functional nanoparticles? If it is not like very secret, if you can kindly tell the composition. Has it already been patented? Then I'd like to ask the composition.
Although already patented, but lot of it's already it is we are as per it is the non-disclosure agreement with the company.
Okay.
Another 2 years we should not disclose anything. So I can tell that it is what is the key property or key material it is inside the coating. So this this is a nanoparticle type of coating.
Yeah.
And so the nanoparticle, it is the role of nanoparticle is which gives it is a nano surface roughness.
Okay.
This is a main this we are we are not, it is a a genius. This we are imitating God's the already it is existing technology. So this lotus leaf, what is that? It is in a technology, it is in a behind. So these protuberance, so which gives it is a the surface roughness. And over the protuberance, there is a it is a paraffin film, which gives it a low surface energy. So that is a simple two combination of it is a surface roughness as well as surface low energy, which gives it is a hydrophobicity. So that is a is a kind of mimic effect. So this nanoparticle in our composition also, it is a it is a used, it is a special nanoparticle which gives it as a surface roughness. So nano surface roughness, and a very functional that slow surface molecule we use. The thing is, it is a why we are very successful for making such composition, because it is although many technology available in the country, not only it is a in the world, it is a there are it is a many key players are there. But the thing is, it is a the requirement for it is a PV application, it should not reduce the transmission by using of any simple coating technique. So that is a very key requirement. The composition should reduce any transmission as well as its a power generation. So the original panel, it should not reduce any power. Otherwise, it is a no company, no industry would prefer this one. So that is a one thing. Another reason is it is a by you have to make it. It is a curing by it is a ambient condition. You just imagine if you want to coat on it is a panel in the field. What is the temperature you would expect? You would expect it is in the field. So in some area it is a 20, 20, 30, 40. In summertime it is, you could expect it is more than it is a 40. So that is what it is a I'm audible?
Yes, sir.
Yes.
Yes, sir, you're audible.
Yes. So the composition should cure at its ambient condition. With ambient condition, it should give it is a high transmission as well as a hydrophobic property. Once if you reach that these two property by using of ambient condition, so you are a more successor. So that is what it is a key requirement for getting this composition. So no coating it is a available which having it is a high transmission obtained by it is a ambient condition. So there are coatings available that you need it is a curate at it is a high temperature. Okay, so you cannot go it is a high temperature on once if you apply on panel, so 100 degree, if you go 100 degree, so backside it is a there is a connector, so the electrical connector will spoil. So it is you cannot it is use any temperature. sometimes what will happen, it is a laminated, this panel laminated with the glass, and also inside it is there is a one EVA film, ethyl vinyl acetate film, and it should not also melt. If it is a melt, what will happen, it is the air will penetrate and it will kill the panel. So that's what it is. Any coating, if you develop, the coating should be curable at ambient condition without losing any transmission, without, with easily getting a hydrophobic property. If you can achieve that, it is you are more successful. So that is what it is the key.
Okay, sir. Thanks a lot. Another small question, sir, that previously you have shown the XPS, which is basically most likely giving light to the interaction of the surface coating. So what kind of bond from the XPS you have observed from this initial ZR O2 SiO2? So it is a covalent bond or like?
Yes, actually, it is this is a very good question. What you're asking. So recently, we have submitted article in solar energy materials and solar cell. And what is the uniqueness? It is initially we submitted paper in ACS, advanced applied materials and interfaces. They ask what is it is a uniqueness of your coating. And what we mentioned that you see that it is a glass having it is a silica bond. So SiO. Okay, you remember it. So so this is glass, that a panel comprised of glass, which that mainly that it is a composition. It is a silica composition. SiO. That is again, it is a connector. This is a multiple network. It is a silica network, and very difficult to coat by using a simple, it is a coating process. So unless if you are not creating, it is a some kind of surface treatment, so you could not, it is a make it is a covalent bond. Okay, so we did it is a some type one kind of, it is a surface treatment. I cannot disclose now. So which create it is a hydro OH group on the surface, glass surface, and it's a special treatment. And after that, it is a when you spray this a saline, so it will make it as a covalent bond. So that is it is a very that you can easily study by using of it is a FTIR. You can see that it is in the composition, bonding composition of it is a, so our some SiO, and again is Si, it is a bonding. You can see that very easy network. You can see in the coating itself. So from that, it is we clearly seen that it is a covalent bond.
Okay.
Yes.
Sir, regarding the mechanical stability and the durability, what kind of test have been performed, or we should rather use not only for a solar panel, but other, suppose we are interested to characterize a coating, its mechanical stability, durability, then we should go for the knife scratch or abrasive test or XPS, or like in which, suppose I have made a coating over a oxide particle. So if somebody asks me to ensure that, how can you ensure that this coating is, it will not come out? So
there are a number of standard tests available. So one, it is a Scotch tape test, very simple test. Scotch tape test. So simple, it is a Scotch tape test.
Scotch tape test.
Scotch tape.
Okay.
You know that sellotape?
Yeah.
Sellotape test. Okay. Scotch tape test. So if you put it is your it is a standard American standard test Scotch tape this is that special number of tape is available. So you can use the tape, and then it is a tab. There is a length you have to put, and then it is a, you can fastly you can remove. And you could, if you can, it is a use 10 times on one place, and continuously monitoring each tape test. It is a transmission loss or any physical changes in the coating. So that is a one good basic test. Another one, it is a crack meter test. So what happened, it is a, they will, so we have to make it, it is a, there is a crack meter line. It's a square line, you have to make it. And then it is a, you can observed by, it is a, SEM, FESEM, and you
Sir,
can
please
see
tell
that.
me the name. Sir,
Yes.
what is the name of the test? The second one?
Croc meter test. Croc, COROCK, croc meter test. Okay. So this is the second test. Another one, it is a pencil hardness test.
Okay.
With the different, pencil hardness you could make. And then other test, it is a, abrasive test, what you mentioned that. So abrasive test, it is a very hard test until unless if you are coating, it is a very hard type of coating. So sometimes it is a, hard coating withstand this test. Okay. Another, if you want to make it, it is a, there is a test called, it is a hydrolytic test. So that is what it is industry people, it is a, demanded. Okay. So if you have an autoclave, if you coated sample, you can keep it in the autoclave and then heated at it is, with the water heat, you make it steam, it is at 110 degrees centigrade for 1 hour. And after that, you can examine it as a transmission or any other optical property. Okay. So if it is, if you observe any changes, so that coating, it is failure. So this is what it is, a number of mechanical tests available in the standard way. So it depends on the, it is a people interest, industrial people, it is a, they may ask it is a pencil harness test, or someone it is asking hydrolytic test, someone will ask it is a croc meter test. So many things. It depends on the, it is a industry, and depends on the coating type. You can choose what mechanical test you can go ahead. Yeah. Any other question?
So all the coating, not only for the solar cell anti-reflective or dust cleaning, all other functional coating is making a covalent bond with the core material. Is it so? Or there may be some like adsorption kind of stuff also? Or it's a covalent?
If it is a coating, it is having kind of, it is a covalent bonding between the substrate and the coating.
Between the
And
particle and the shell, between the substrate and the coating.
yeah. So any actually, it is, if you want to get high mechanical stability, the coating should be mechanically should be covalently bond with its substrate. Then only you will get it is a high mechanical stability. Otherwise, it is about a physi adsorption or chemi adsorption. It is how you can get it is in a high stability.
So this XPS will confirm, XPS can confirm whether it's creating a covalent bond or not.
No, it is an XPS. It won't give it as a covalent bond or not. How you can, it is a my very simple technique. It is a, you could see that it's a for example, it is your substrate is silicon. Okay, your coating material, it is a somewhat it is zirconia. Okay, what kind of bond you will expect covalent bond? Can you guess that it is a what kind of bond you will expect?
Because of the presence of silica, SiO, Si kind of bond.
SiO and zirconia you may get, no?
Okay.
Right? So the coating material is zirconia. If it is zirconia, then the zirconia may contact covalently. It is a bonded with, it is a silica substrate. In such a way, it's zirconia, oxygen, and Si. Okay. So this kind of, it is a bond and bond stretching. It is a you can easily identify by FTIR.
Okay. Okay. I understand. I understand.
Instead of the XPS. XPS you cannot identify that the covalent bond.
Okay. Only the composition. Yes, sir. Yes,
Yeah,
sir.
you can do it as you can analyze the composition. Okay,
Hmm.
and oxidation state you could see that. But
That's
you know,
dangerous. So
it is this
graphene and,
FTR. It is a very easy technique.
yeah. So for graphene and other kind of coating, maybe it depends on like graphene will make some similar bonding with all of the substrates, right?
Yeah,
And
but you some of I'm not objecting. It is some of the it is carbon based type. You could see that. Okay, XP is also you can see that.
okay, okay, sir.
Okay.
Okay.
Okay. It's not. It is a very some some case it is you can use it is FTI or some case you can use that XPS. Yeah, depends.
Yes, sir. Yes, sir. Thanks a lot, sir, for the informative talk. Now, I'd like to ask Jyoti ma'am to please give vote of thanks, and if any other question from the panel, to please read. Jyoti ma'am, go ahead, please.
Good afternoon, sir. What a wonderful session we have, sir. And here is only one question and one request. And the question is is this special coating available in market, sir?
Yes,
Okay, from where we can get it or
you can search in Amazon also.
okay, sir. Thank you so much. And here is a request from my colleague. Can we have this picture for academic person purpose, sir?
What we have
Can you share your PPT, sir, for
no
academic?
no madam we cannot share. Okay, so this is technology oriented. It is a since it is committed with it is a company.
Okay.
Yeah.
Okay. So here, going to give vote of thanks, sir, respected Dr. Saktivel, sir, our most valued invited guest, Dr. Neetu Paliwal, Dean, Faculty of Science, Dr. Pragya Srivastav, Head of the Department, all my dear faculty members and students. It is my privilege to have been asked to propose a vote of thanks on this occasion. And I, Jyoti Rawat, on behalf of Rabindranath Tagore University and the entire Faculty of Science team, extend a very hearty vote of thanks to our honorable speaker for gracing our wonderful lecture and sharing knowledge with us. Your findings and opinions in this webinar, sir. A very big thank to you, Dr. Sir, and for these efforts toward this joint step ahead to start some of the collaborative research. We are also looking forward to you, sir, to have more ideas of doing, adding, and performing more good work with our research scholars and other researchers also. And I must mention our deep sense of appreciation to Dr. Nitin Vats, sir, Director IQAC, who has motivates us to organize this series of research-centered webinar. I also wish to express my gratitude to Dr. Sangeeta Johri, ma'am, Coordinator IQAC, for providing encouragement on this webinar. And I would like to express our sincere thanks to Mr. and our all IT technical support team also, and all the people who are directly or indirectly joined us. Thank you so much for all. Thank you so much, sir. And we are looking forward to meeting you soon, and hopefully you will come to our university and have some visits in our campus also, and we will get more beneficial from your knowledge and research also, sir.
Thank you so much. Once again, thank you so much to all and Dr. Sudhasana Ray. So thank you for your kind invitation.
Yeah,
So,
just one request. If in from your institute, is there any course or training program or certification program on this coating characterization and this coating durability, mechanical stability with carbon-based coating, with any kind of coating, not only solar or this purpose, maybe some so that we can be benefited and
let me know, madam. If they are conducting, mostly it is there is a center, it is a Soldier Center.
okay.
Heading by Dr. Subhastri, and maybe you can contact her and she might have it as a conduct some kind of things.
Okay.
Because all the basic that she is doing a lot of coding and characterization.
Okay, sol gel.
Yes, yes. So what you asked, it is abrasive resistance and other coating technique. It is in the mechanical tester. It is they have, so they might support you.
Okay, sir. Okay, sir. And after the
Thank you.
COVID situation, becomes normal, then we will be extremely happy to invite you in person to our campus. Our students, faculties will be extremely benefited
Thank you, madam. Thank you. You can also visit us when you have time.
and motivated from your talk. So thank you so much again for your talk. Thank you, sir.
Thank you, madam. Thank you.
We
Thank
are
you.
very much looking forward to visit your center also after this
Yeah,
COVID.
yeah. Please, you can visit, because right now it is, we are restricted
Yes, of course.
people, and
Yeah.
once if the pandemic, it is, and still now it is, we are not permitting visitors. So I think it is, if in the near future you can visit us and visit our center as well, and
Yes.
yeah, you can see our
Thank you.
facility. Thank you,
so
thank you,
much.
thank you.
Thank you, sir.
Okay, shall we?